Welcome to the Sheldrake-Vernon dialogues with myself, Mark Vernon, and Rupert Sheldrake. Hi there, Rupert.
Hello, Mark.
We're going to talk today about form and forms as a key principle that has been used in the understanding of the cosmos and has a very interesting relationship in the modern world, modern science, Rupert, which you know a huge amount about. But I thought it might be helpful, first of all, to do a bit of scene setting and talk about the notion of form in the ancient world and the medieval mind. It can be related probably very neatly to Aristotle's notion of the four causes. So Aristotle put this proposal together that has been very influential, that when you're wanting to explain something, you need to do that in four ways, which are sometimes summarized as the mechanical, the efficient, the formal, which is related to the notion of form, and then the final. It's worth just noticing actually that Aristotle's cause doesn't really mean like the modern notion of cause, a sort of external force that acts on something. For him, a cause is much more like the rationale or the relationship with other things that something's in. It's kind of intrinsic to whatever it is you're discussing, rather than external. So with a lot of these terms in the ancient world, you have to do a bit of work to try and get a sense of what was really meant. But when Aristotle comes to the formal bit, he really means what the inherent meaning or the purpose, the sort of why, the what is it to be the thing that he's talking about. And it might be anything from, a stone, a planet, to a plant, an animal, a human mind, and so on. So it's a very general notion, and I don't know. I think often as form and formal causes. I think you could say even that in the modern world, you might say the legal system. We all live in sort of in countries that have legal systems that shape the way that we live. They affect the way we behave, and if we transgress certain laws, then things will happen to us. And the formal causal part of that is the legal system itself. It's the structure of laws. And there's a kind of mechanical bit that happens when we obey the law. I cross the road in the right way. And there's the efficient bit, which is the actual business of moving and motion and energy and so on. And then there's the final bit, which is laws exist for the purpose of making a good society. But the formal bit is the structure itself, the kind of inherent principles that we live by. And so forms and formal causes were like that. And in Plato, the notion of forms or ideas plays a huge part. And that's really what I think Plato means. It's kind of like the intelligence that's either inherent in a particular entity or indeed in the cosmos in itself. And so it structures the way things are. And that intelligence is quite living in Plato. He lives very much in this moment where the animate world is still alive to people as well as the more analytical world. And so forms, I think actually they're quite like angels. When angels are discussed in people like Pseudo Dionysius, they're the medium that transmit the intelligence that ultimately comes from God, but into all things. And so these different kinds of angels operate at different levels of reality, from the angels of particular things and places through to those that structure more general dynamics. And so forms can be thought of as like that, and beginning to come more to the way that they might be talked about now, or indeed pushed to one side now. I think a pivotal moment comes with the work of Francis Bacon and his, particularly his book, The Advancement of Learning. And there he says, look, this old way, and he discusses Plato and Aristotle and other figures. It's all very well to have this notion of formal cause, final cause, but it's an obstruction to what we want to investigate now in the modern world through mechanistic science, which is much more limited to the mechanical and the efficient. And he also much more means mechanical and efficient as things acting on each other extrinsically rather than intrinsically related to one another. And so you can read in the Advancements of Learning how he talks about how Plato philosophy, it mingles theology as well as science, and he thinks that the theology needs to be put to one side. Bacon doesn't necessarily dismiss the theology, actually. He has his own very active theology in relation to science, but he thinks that on a sort of practical level, the formal needs to be put to one side, the theological needs to be put to one side, so that you can get a much clearer grip on the physical. So you can begin to see the separation of these things and the dualisms that become so important in modern science, so that you can get to the material by not having to investigate the mental, for example. So I hope that makes some sense to you, Rupert. It fits your picture of kind of where we've got to with this notion of form, but that you've picked up so much in your own work.
Yes, thank you, Mark. Well, I think for me, one of the starting points is that the whole world we live in is full of forms. I mean, it's just a matter of our own experience. I mean, when children are learning to speak, they learn to recognize and name forms. So go around pointing, say, doggy and cat and flower and that kind of thing. And so there's a sense in which forms are both outside there in the world all around us. As I look around me, everything I see is a form: telephones, flowers, plants, windows, doors, desks, bits of paper, books, mugs, etc. We also have names for these forms. The Indians say, bring them together, nama rupa, names and forms, that these are structures, both structures in our minds, the names, and also the recognition of the forms are in our minds, but they're also out there. And a lot of science, although Bacon emphasized the mechanical side of science, and mechanistic science and physics emphasizes the mechanical, it's impossible for the sciences to ignore forms. And if you look at taxonomic botany, for example, you have plant taxonomists classifying plants, starting from Linnaeus with the modern phase starts with Linnaeus, his binomial system, the sexual classification of plants based on flower structure. And then you go to Kew Gardens at the Royal Botanic Gardens here in London, and there's a herbarium with tens of thousands, maybe hundreds of thousands, even millions of pressed plant specimens, because the ultimate reference, the type specimen for classifying a species, is its form as pressed in Kew herbarium or in other herbaria. And we classify animals by form as well. The British Museum has a whole depository at Tring where they keep bird feathers and bird skins, because you classify birds by their form and their feathers. And even chemistry is a science of form. If you look at chemical formulae, they are pictures of the form of the chemical. The structures of proteins, the formula of methane or of carbon dioxide. When you look at even those ball and stick models, those are forms. And indeed, in quantum physics, when you're looking at the orbitals of electrons around a nucleus given by quantum matter fields, and there's a whole series of orbitals which are standing waves which have forms surrounding the nucleus. So the whole world is full of forms. Our minds are full of forms. We recognize forms because our minds inhabit a world of form. We instantly recognize forms, even though individuals differ. We can use the word tree to apply to hundreds of different kinds of trees. And all of them have something in common which we'd find hard to define in words, but which we can instantly recognize, through the way our minds, as it were, resonate with forms in the outside world. And our minds create forms because our dreams are full of forms as well. And there's no external stimulus at the immediate time we're dreaming. Our minds can just generate forms, and we live in the world of them. So I think this is simply a fact of nature. Then there's the question of how the sciences attempt to explain them. And as you say, in the ancient world, Plato had the idea there's archetypal forms or ideas beyond space or time, which are the archetypes of all forms in nature, transcendent ideas and a kind of transcendent mind. Aristotle embedded them in nature with animals and plants. He thought that the soul of the animal or plant was the form of the body. The primary function of the soul was the form of the body. So the form of a beech tree is given by the beech tree's soul, and the soul of the beech tree contains, as it were, the formal cause, the cause of the form of the beech tree. It's like an invisible shaping influence that shapes the beech seedling as it grows and attracts it towards the form of a mature beech tree. So for Aristotle, the formal causes of all animal and plant forms, and indeed of anything else that had form, was given by its soul. Now, as you said, in the 17th century revolution, all souls were abolished from nature, and you were left with just material and efficient causes, the matter that things are made of, and the energy that, the moving energy that propels them or pushes them or pulls them. And so the whole system of explaining form was discarded. And it was discarded in physics first. And when you're dealing with billiard balls or falling objects or colliding objects, basically it was taken for granted. I mean, ironically, physics wouldn't work without having forms implicit. I mean, even billiard ball physics presupposes perfectly round billiard balls, perfectly smooth billiard tables, as little friction as possible. Billiard ball physics wouldn't work if you were starting with rough rocks that had just sort of fallen off a mountain. I mean, it's a kind of abstraction that depends on those forms. And mechanistic science, which treats nature as a machine, of course, implicitly requires forms because machines have forms. Clocks have cogwheels and pendulums and escapement mechanisms and so forth, all of which can be made in factories, and all of which have forms, and all of which have to be designed. But all of that was sort of taken out of nature by mechanistic science, and the intelligence that led to the form of the machine was somehow external to science, which dealt only with the matter and the energy and the forces acting on the components. So I think that the challenge within the sciences is to understand how forms can be understood, because they can't just be understood in terms of the matter and the energy. I mean, an obvious metaphor is a building site. You can't build a house without the bricks, cement, timber, etc. And those all have to be delivered to the building site, and you need the energy of the builders and cranes and things to put things in the right place. But the architect's plan, the form of the building, is not the same as the bricks that it's made of, or the energy that's used in constructing the house. And the same energy and the same bricks could be used to build houses of different form, shape, or plan. So the great vacuum in contemporary science is how to explain the form of things. And to some degree, that vacuum has been filled since the 19th century by the concept of fields. And fields are, as it were, formal causes, as we discussed in our discussion on fields, that fields actually impose form on material processes. A magnetic field, when you sprinkle iron filings around it, shows these lines of force of the iron filings, which are structures within the field of the magnet. They're not inside the magnet, they're around the magnet. The field is an invisible structure around the magnet. And the Earth's gravitational field gives the Earth its round shape, as the Sun and the Moon's gravitational fields give them their round shapes. And the gravitational field also helps the Moon to stay in the right orbit, and the Earth and other planets to stay in the right orbits around the Sun. So these are kind of formal causes. And within biology, where we see the most elaborate forms of all in animals and plants, there's been an attempt through molecular biology and mechanistic biology to try and explain all this just in terms of the component molecules, genes and proteins, membranes, etc. The trouble is that these explanations can't work because they're a bit like trying to explain a house just in terms of the materials delivered to the building site, because they simply can't. The genes don't have a plan for the full plant or animal. They have sequences of bases that specify the sequence of amino acids in proteins. And then the way the proteins fold up isn't explained just by those sequences. That depends on forces and fields. But the whole organism just can't be explained that way, which is why ever since the 1920s, some biologists have thought that there have to be another kind of field, form-shaping fields, morphogenetic fields, fields to do with coming into being of form, morphogenesis, coming into being. Invisible fields that shape leaves and petals and limbs and eyes and spleens and livers and so on. And that's the tradition within which I work myself. And I think that morphogenetic fields are essential if we're going to understand the forms of living things. And they're rather similar to what Aristotle called the vegetative soul that shapes animals and plants. So they give structure, they give pattern. That means they themselves have structure and pattern, but it's invisible. It's more like a thought than a thing. And we're familiar with invisible patterns because our whole minds are full of invisible patterns. So there's a kind of affinity between mind and form, and the causal factors of form in nature, these fields, morphogenetic fields, are in some sense mind-like. They have intentions or goals. When a plant is developing, it develops towards an end point, the mature plant. When an animal embryo develops, it's not just trying to be an embryo, it's trying to be a mature animal that can survive and reproduce. And so the developmental process is drawn towards that goal, it's pulled towards it. And if you disturb the embryo as it develops, it can often get to the same goal, even even by an unusual route. If you take a sea urchin embryo and cut it in half, you don't get two half sea urchins, you get two small but complete sea urchins. Each of them adjusts and goes along this trajectory towards the correct end or goal. So there's this whole area of causation, what Aristotle called formal causation, that's still enormously relevant, but which has been completely left out of modern science and implicitly filled with fields as formal causes. But this is just a great gap in the modern scientific worldview, which I think has to be filled in to get a more complete understanding of nature and of mind.
And presumably part of the challenge for the tradition that you're working in is the rejection of the notion that there's aspects, well, maybe the nature of these forms and fields, this soul, is more mind-like, as you say, like a thought rather than more matter-like, like a push and pull of the mechanical philosophy. As you're saying with the sea urchins, these amazing examples, it's like there's a kind of intentionality in the embryo that means that it tries to find a way in spite of impediments. There is a purposiveness, and it's a kind of intelligence as well. It's not just a kind of abstract law unfolding as if like a computer code. It's much more adaptive and sort of smarter than that. And the other element which I was thinking when you were talking was that science itself, I imagine, depends on the existence of forms. Because what happens when the scientist works is that their mind meets the form that they're studying, which too is intelligence and minds like. And it's in that meeting that the science emerges. A friend of mine who's a biochemist She talks about how when she studies viruses, say, she imaginatively identifies with the virus and sort of feels into, intuits into what it might like to be for the virus to reach into the cell and what happens to the proteins and the various structures and so on. And in her mind, then come possibilities for understanding what's going on, which then are checked out, maybe in a experiment, maybe in a computer. Of course, it's all put to the test. But her mind meeting the form of the virus that she's studying is absolutely fundamental to the scientific process. So, this sort of resistance to the idea of the mind, like in nature, is um, sort of denied almost by the very activity of science itself, let alone the kind of explanation that you need to explain, as you're saying, the forms of things all around.
I think that scientists actually implicitly accept something mind-like in nature through the concept of laws of nature. Because laws of nature, at least in the way they're usually conceived, the ideal law of nature in science is a mathematical law. The prototype was Newton's law of gravitation, and then Maxwell's equations of electromagnetism, Einstein's E equals mc squared, etc., etc. I mean, what people love are mathematical laws, and these are considered the ultimate scientific explanation of nature. And even people who want to find a grand unified theory of nature or theory of everything, sometimes say that the goal of the entire scientific process is to end up with a formula that you can print on a T-shirt. There's this idea of mathematical laws. But what are mathematical laws? I mean, they're mind-like. I mean, mathematical laws don't exist out there in nature. You don't sort of pick up a stone and find a mathematical law lying underneath it. You don't look into the sky with a telescope and see an equation written in the sky. These are inferred as being deep underlying principles of the whole of nature, which have a mathematical structure and order, which is mind-like. Certainly not material, and it's certainly not energetic. So there's a sense in which the sciences, insofar as they deny formal causes, are being completely hypocritical, because the entire scientific endeavour since the 17th century onwards has been about trying to reduce things to mathematical laws. Physicalism, its attempt to reduce all of nature and life to physics, then wants to reduce physics to mathematical laws, and physicists have got further than most in pretending it's all just a matter of mathematical laws. So, in a way, these mathematical laws of nature are a hangover of Platonic philosophy, or rather Pythagorean philosophy, which preceded and influenced Plato. So I think we've already got these immaterial principles, except that most scientists don't realize that's what they're actually believing in, and would be hard-pressed to explain where they come from or how they subsist if they were forced to think about it, but most of the time they don't think about it.
Yeah, you reminded me of when my old physics tutor, Carlos Frank, was on Desert Island Discs. And towards the end of the discussion, they became more reflective. And Carlos's convictions came out. He summarized it as basically God must be a physicist. And what he meant by that is not that God's a kind of demiurge tinkering with nature, as if he's a sort of intelligent designer. But the very experience of doing physics for him has a spiritual element. It's like his mind is not only encountering the world, but is somehow encountering the divine mind that within which all this was imagined or formed, to use the word of the discussion, that he is able to get some glimpse and participate with as well. I think Einstein said something quite similar to that, actually. The imagination often was the way he talked about it. But he believed that the scientific imagination has been given to us not just as an arbitrary tool that, luckily for us, enables us to come up with with these laws, but as the means of actually participating in the imagination that is the cosmos itself. And I mean, I think this matters existentially as well, because It's about how we understand our relationship to the world around us. And again, part of the knock-on effect of this move by Bacon and others, for good reason, to develop a kind of modern science, to develop technology, to be able to manipulate things and so on, which we all gain from. But there's a shadow to it, which it leaves hanging the question of our relationship to the world, both the natural world, the cosmos itself, and even, to one another. Because when laws are taken outside of the objects that they influence, so they're not ensouled in the object, like you were saying, but they're um, somehow external acting on. It leaves this model of how we're all external to each other, acting on each other, a bit like very elaborate billiard balls knocking on the bays, as you mentioned as well. And what you don't get is the sense of a kind of inherent sympathy and communion, that we're actually not reaching out across a sort of abyss that actually separates us, but actually we're participating in a common experience of life. And to be able to align with that and to realize that, that is the way, not just that we humans feel we need in order to be able to relate and love and exist with one another and so on, so we don't have this terrible existential isolation and loneliness, but that's actually what's required to understand the way that we experience life as well. I think that there's a tremendous amount at stake in all this that matters in terms of yeah, our well-being, and the modern sense of existential angst and meaninglessness and so on. I guess that's partly why people respond to your work, actually. I guess most readers aren't approaching it purely from the scientific point of view because they're not scientists, but they feel in the way that you write that there's a lost sense of participating with the living world, and that they're drawn to it because that comes back to life in what they read.
I think I agree that the normal this view of within the sciences of this participation in the mind of God through the equations and things. A lot of scientists, when they retire or get the Nobel Prize, become somewhat mystical about the relation between science and God. Uh, the trouble is that I think that they have such a limited view of the divine imagination. Physicists are dealing with mathematical equations. That's what physics is about, or it's become to be about that. And so therefore they think of God as being all about mathematical equations, as a mathematician or a physicist. Um, but this kind of Pythagorean view of God is a very limited view. As Plato showed, it's not enough just to have mathematical proportions, harmonies and ratios. You need forms as well. It's the assumption that you just a few basic physical formulae can explain the flowers of a rose or the shape of a giraffe is a pure assumption. No one can possibly calculate these forms from first principles. So I think what it's done is impoverished our view of the divine mind. So it's been reduced to a few basic mathematical equations and ideally to just one, the ultimate theory. Whereas actually the divine mind and imagination is teeming with forms and is the realm of all possible forms, not just ones that do exist and have existed, but all which could exist. That the divine imagination contains all possibilities. I think Saint Anselm was one of the people who pointed that out. That if it lacked any of these possibilities, it would be less than complete. So it has to contain all possibilities, all the forms, everything we experience, everything that is part of our life and our experiential, participation in the world is to do with these forms that are ultimately in the divine imagination. And to reduce it just to maths is like having a school curriculum where the only important subject was mathematics and mathematical physics and all the rest was of no value. Rather like the national curriculum at the moment, where art subjects are sort of withering away in Britain. and in universities and schools. They're not useful. It should all be about maths and engineering and things. So I think it's this impoverished view. And when we recognize that actually the ultimate mind, the source of everything in the cosmos, is full of forms, it is full of imaginings, and that what we see in the natural world, the plants and animals, are within that imagination. It doesn't necessarily mean that God, I don't think it does mean that God imagines them and then designs them like an engineer and like the 18th century view of the designer God, the clock-making God. I think rather the imagination is indwelling in working through nature, and that the forms of nature all have their own creative potential and imagination as well, and that there's this development and evolution of forms in the entire cosmic evolutionary process. And all these forms participate in the divine imagination and in the imagination of all the creatures in the world. So this, I think, the problem with the usual scientific view is just this incredible impoverishment of this realm to, equations of physics, and the idea that all other scientific explanations are merely provisional, and when you get down to the real thing, you'll be able to reduce them to a few physical equations. It's just a truncation and impoverishment of our own minds and our view of all other minds in nature.
Yeah, and I think that it's important to stress that, like you're saying, that this is not a view of the divine mind as having a whole bunch of templates that is sort of being tried out, tested for functionality or something. That's still that's too modern a notion as well. It's much more as if the divine mind is active in all things, drawing all things back to itself in the myriad ways that the entities in the cosmos can become not just not just show their mind's likeness, but show their godlikeness as well. So this is in Plato's understanding that the good, the beautiful, and the true themselves are forms that are drawing and active in all things in order that things can become that which is good for them, can express their truth, their relationships, their intelligence, their beauty too, that the human mind is so alert to as well. It's much more like well, actually, I think Carl Jung was onto this. I recently read Bernardo Kastrup's book on Carl Jung's philosophy, and he makes the case that Jung was actually interested in how what can be called forms operate throughout the cosmos. He talks a lot about sympathies. Things relate by resonance, by kind of harmony, by shared intentionality. But what's happened in the modern world is that that's all got a bit split and separated. And whilst on the one hand, there's the kind of form that's thought of as force and cause acting on each other like rocks colliding. But then you, at the other end of the spectrum, separate from that, you get a rather magical thinking that can appear as well. And this is often how Jung's notion of synchronicities is talked about, as if there's some kind of sudden cut through this otherwise mechanical cosmos, when you see the butterfly that is so incredibly meaningful to you, or when what you were saying in your mind is spoken by another person 5 minutes later in the encounter. Jung says, no, we've got to join these two extremes up and see that actually they're both subsections of a continuous sympathetic activity in the cosmos, that's both once about the intrinsic meaning and purposes of all the things in the cosmos, in a kind of dance or an exchange that is partly energetic in the physics sense, but is also energetic in the soulful sense. And sometimes that can be regularized. And so you can use maths to describe those sympathies in the subset of entities that behave in that very strict and lawful kind of way. But don't confuse the underlying sympathy with the lawful abstraction of it. And then sometimes these sympathies sort of take us by surprise, and so we think of them as synchronicities, as if they're random occurrences that are somehow full of meaning as well. Well, that happens, but Bernard de Castrop is arguing that Jung, in a fuller version of his ideas, was moving towards saying, but that too is a kind of exceptional instance of the general case, which is this continual unfolding, this continual emergence, drawn as much by from the top down as the bottom up, would be another way that it's expressed now. And because that which is good, that which is beautiful, that which is true, are other kinds of form that are active all the time, even in what seem to be completely mechanical instances. So I think that what you're saying is that um, this isn't just required to forms aren't just required to explain the world as we know it, but they're inviting a kind of paradigm shift back to a participative nature of the world, and that all things participate too in the divine mind. And I guess that notions like panpsychism, these approaches to understanding nature that use the mind like rather than the matter like as their fundamental modality. One would hope, from my point of view, no doubt from yours as well, that however it shapes up in the fullness of time, this is a kind of direction of travel that science, at least in some parts, is undergoing.
Yes, just one final note to that. I think that the need for it is felt within science, and the sticking plaster, as it were, to cover up this need is by the use of the word information. So there's a need for something formative in nature, and this has now become so where people talk about quantum information or the informational cosmos and that kind of thing. I think the problem with that is that the word information immediately creates a kind of jargon-like fog in the minds of people thinking about it, because it implies information theory, which is all about bits and how you send messages down telephone wires originally, and it's now about how you process things in computers and stuff. Information is about putting form into things in formation. And I think it clouds the issue to talk about how you code the form and then retrieve it and transmit it, when we can actually think much more clearly and directly about form itself. So I think that one of the things we need to do is to get back to thinking about form itself and remove the fog of all this talk about information. I mean, it's useful in its own way, and I'm not saying it's totally worthless and all that, but I'm saying it occludes or blocks clear thinking about form. And so I think that that's why in our discussion now, I think it's good that we're focusing on form itself, as we can immediately think about it, recognize it, see it, experience it.
Yeah, no, that's a very good additional thought, because it's so alive, actually, isn't it? Integrated information theory
Yes.
is one version of that, and actually, your collaborator, who I know as well, Alex Gomez-Marin, he's written a lot about this, actually, hasn't he? And I guess wanting to make the kind of point you're suggesting there, don't get lost in the woods because you're so attentive to the trees. Yeah. Well,
Good.
look, thank you. There's a sort of sense of a return with difference, perhaps, but the notion of form really mattering, and in a way, it never went away at all. It just got um, occluded by ways of talking about the world, but those ways of talking about the world still require forms in order to keep talking about the world. So, thanks very much indeed, Rupert.
Well, thank you, Mark.